This is Cambridge IGCSE Paper 4 Theory Extended, May-June 2022, Variant 2. Question number 1. The symbols of the elements of period 3 of the period table are shown. Answer the following questions about these elements. Each symbol may be used once, more than once, or not at all. Write the symbol of the element which forms a stable ion with a +2 charge. So that usually refers to a group 2 element, which is magnesium. Next is the least reactive in the period. So least reactive as of a noble gas. So it's AR. Then next is used in water treatment. That's actually just chlorine. Next forms an oxide, which is the main impurity in iron ore. Now in the iron ore, there's actually a lot of silicon 4 oxides. So silicon. And E is an important component of fertilizers, which is about, well, in terms of period 3, there will be phosphorus, okay, NPK fertilizers. And F is stored under oil, which is group 1, because group 1 is very reactive. It burns in air, it burns in water, so you need to put it in oil. G is used in food containers, so that we actually use aluminium for that. And then last one is found in the ore zinc blend, which is actually sulfur. Right, next question. Calcium hydroxide is slightly soluble in water. Calcium hydroxide can be made by the reaction of calcium with water. Write the chemical equation for this reaction. So using calcium, reacting with water, and form calcium hydroxide. And actually this reaction produces hydrogen gas, right? So we need to balance this equation. Calcium is okay. Hydrogen, I see that there's 4 and 2 units. So it's actually, 4 units of hydrogen and 2 units of oxygen on the right. So on my left, the coefficient should be 2. All right, next question, sorry. Name another substance that reacts with water to form calcium hydroxide. That will be calcium oxide. Right, next question. When calcium hydroxide dissolves in water, it dissociates into ions and forms a weakly alkaline solution. Suggest the pH of aqueous calcium hydroxide. So because it's a weakly alkaline solution, the pH should be just slightly above 7. So let's say we give 8, right? 2, give the formula of the ion responsible for making the solution alkaline. There will be hydroxide ions. Right, next. Lime water is a saturated solution of calcium hydroxide. Name the gas lime water is used to test for. That is actually carbon dioxide. Next, suggest what is meant by the term saturated solution. It refers to a solution that can dissolve no more solute at a given temperature. This is 1 mark, and this is the second mark. Next question, describe how you would make a sample of lime water starting with sodium calcium hydroxide. So you can actually add the solid into water. And basically after that you just filter it to remove water, to remove the unreacted, not to say unreacted, but more of calcium hydroxide solids that cannot dissolve further. Right? So you need to remember, you need to add excess in order to make saturated solution. All right. 4. Describe how you would test for the presence of calcium ions in a sample of lime water. So we need to use cation test for this. So you can either use ammonia or you can use sodium hydroxide. Right? You can use sodium hydroxide, aqueous sodium hydroxide, which leads to formation of white precipitate that is insoluble in excess. All right, you can refer to the chemical test table for that. All right, not for this question, but you can refer it for your own revision. Okay, next question. A 25.0 cubic centimeter sample of lime water is placed in a conical flask. The concentration of calcium hydroxide in the lime water is determined by titration by dilute hydrochloric acid. Name the item of apparatus used to measure the volume of acid in this titration. Now, because you're measuring 25.0 cubic centimeters, you're actually using a... Wait, pause. It's about the acid. Pause. We're doing acid. So the acid is titrated. We are titrating using this, so we need to use a burette to measure. And two, state the type of reaction which takes place, which is just neutralization. And next, as well as lime water and dilute hydrochloric acid, state what other type of substance must be added to the conical flask. So you need an indicator for that. Next question, 4. The equation for the reaction is shown. 20 cubic centimeters of 0.05 mole per cubic decimeter hydrochloric acid reacts with the 25 cubic centimeters of calcium hydroxide. Determine the concentration of calcium hydroxide in gram per dm cube using the following steps. First of all, calculate the number of moles of 20.0 cubic centimeters of 0.05 mole per cubic decimeters hydrochloric acid. So to find number of moles for this, you need to take volume multiplied by concentration. So remember that volume must be in cubic decimeters, which you need to divide it by 1000, multiply by 0.05. That gives me 0.001. And next, calculate the number of moles of calcium hydroxide in 25 cubic centimeters of the lime water. So we need to use the equation for that, because we are not given the concentration of lime water. So if you use the equation for that, in our equation, the ratio of the calcium hydroxide is, and also hydrochloric acid, the theoretical mole ratio is a 1:2 ratio. So bring that down, and using our data, it tells us that we are actually using 0.001 mole of hydrochloric acid. So it will be half of the amount. Perhaps is 0.0005. And lastly, calculate the concentration of calcium hydroxide in mole per dm cube. So using these two data, we can do the same thing here, which is to find concentration, we need to take number of moles divided by volume in dm cube actually. So you need to convert that 0.0005 divided by 25 out of 1000 decimeter cube, which is 0.025, and we take the 0.0005 divided by this answer, we get 0.02. All right, next question. Determine the concentration of calcium hydroxide in gram per dm cube. So we want to convert this into this format instead. So how can we do that? Now, your unit is 0.02 mole per cubic decimeters. We want to convert it to gram per decimeter cube. So that can be done by multiplying with gram per mole, which is just molar mass. All right, so you need to find molar mass of calcium hydroxide. That can be done by referring to the periodic table. It's 40 plus 16 plus 1 times 2. So that gives you 74. So we need to multiply with 74 times 0.02. That gives me 1.48. Right? So in order to convert from this unit to this unit, you need to multiply with molar mass. All right? Next question, transition elements are found in the middle block of the periodic table. Chromium has several isotopes. Manganese has only one isotopes. State what is meant by the term isotopes. It refers to different atoms of the same element with the same number of, same number of protons, but different number of neutrons. Right, next, state the nuclear number of manganese. You need to refer to the periodic table for that. Allow me to Google periodic table real quick. Manganese. The periodic table tells me that manganese is having 55 as its nuclear number. Next question, complete a table to show the number of protons, neutrons, and electrons in this particular ion. So you read the small number is the proton number, and then to find neutrons, we need to take the mass number minus proton. So take 52, which is a big number, minus 24, that gives you 28. And lastly, to find chromium 3 ion, it has 3 more protons than electrons. So we need to take 24 minus 3 equals 21. All right, that's the answer. Next question. One chemical property of transition elements is that they form color compounds. Give the colors of the following hydrated salts. So the first one is copper 2 sulfate, which is in hydrated form. That's actually blue in color. And the hydrated cobalt 2 chloride is actually pink in color. Next, state 2 other chemical properties of transition elements. So we need to mention not about the color compounds anymore. We should mention about maybe their variable oxidation states. Or we can talk about their ability to act as a catalyst. Right, those are special chemical properties of transition elements. Next, transition elements and group bond elements are metals. They share many physical properties, including the ability to conduct electricity and be hammered to shape. Explain why transition elements and group bond elements conduct electricity. Because they have delocalized electrons. Or you can see mobile electrons in their metallic structure. Next, state the property that describes a material that can be hammered into shape that is actually just malleable. Right? Next, transition elements and group bond elements differ in other physical properties. Transition elements are harder and stronger than group bond elements. Describe 2 other ways in which the physical properties of transition elements differ from group bond elements. So there will be in terms of the melting point, which is way higher, and also higher density compared to group 1 metals. Right, next question. Question number 4, fluorine and chlorine are halogens. Suggest the appearance of fluorine. So it will look like a yellow gas, right? Pale yellow gas. Next, fluorine reacts with sulfur to form a compound which has 25.2% sulfur by mass and a relative molecular mass of 254. Determine the molecular formula of this compound. Now, so we need to use a table for that to allow us to calculate better the empirical formula first, right? So, given that this compound only contains sulfur and fluorine, the percentage by mass, okay, we just assume that the mass is 100, will be 25.2 and 74.8 respectively. Oops, I think I switched it up slightly. Give me a moment. Now next, let's find the number of moles. So you can take 74.8 divided by the molar mass of sulfur. Give me a moment. Let me show the periodic table. That's actually 32. And for fluorine, it's 25.2 divided by 90. And we get okay, we actually get a very long decimal from both answers. So it may be appropriate if we straight away see the comparison by dividing one by another. Let me try that real quick. Am I dividing it wrongly? Give me a moment just to look at the mark scheme. Something is wrong. Ah, wait, did I accidentally do the same thing, same mistake again? Sulfur is just now I was correct. No wonder the answer is weird. Give me a moment. Correct this quickly. Sulfur is 25.2. Fluorine is 74.8. So we take 25.2 divided by 32 and 74.8 divided by 90. Then the answer should be normal now. And 74.8 divided by 2, I get 3.937. So you can just straight away take this divided by this to see the comparison in terms of the sizes. There will actually be a 5:1 ratio. All right, so the empirical formula is SF5. However, we're not done yet. We need to find out the molecular formula by taking SF5, okay, multiply with N, the masses, and that equals to 254. So we need to do basically the mass of this one. It's 32 plus 19 times 5. So that gives me 32 plus 19 times 5. 127, N equals to 254. So N equals to 2. So the real molecular formula is S2F10. All right, S2F10. Okay, it's not an easy question because of the large numbers, but it's the same concept, right? And make sure you copy it correctly. Don't be like me just now. And divide it to find the ratio, and then you can use one of them divide by the other to see the factor, and it's a 1:5 ratio. And with that, using this, the empirical formula, we can use it to find the molecular formula. Now, next question. Nitrogen trichloride is a covalent compound. Complete a dot and cross diagram to show the electron arrangement in the molecule of nitrogen trichloride. Show outer electrons only. So, nitrogen is a group 5 element, whereas chlorine is a group 7 element. So with that said, their outer electrons are 5 and 7 respectively. For nitrogen, it needs another 3 to achieve stability. So I would say it will contribute 3 for sharing. And for chlorine, it will contribute 1 for sharing because it needs 1 to achieve stability. So it will contribute 1 for sharing. So we will have nitrogen will have 2 free electrons. Sorry, I should say that it will have 2 non-bonding electrons, and then it will contribute 3 for sharing. For chlorine, it should have 6 non-bonding electrons for each. And it will contribute 1 for sharing for each of the chlorine atoms. So that is the structure. All right. The marks are given as of the 3 bonds are correct, and then 6 non-bonding electrons for each chlorine atom. That is another mark, and also the nitrogen non-bonding electrons is another mark. Now, next question. Lithium chloride is an ionic compound. Complete the dot and cross diagram to show the electron arrangement and charges of the ions in lithium chloride. So, lithium is plus because it's a group 1 element. Chloride is minus because it's a group 7 element. And we need to draw the shells. Now, lithium is originally is a group 2 element. Sorry, group 1 element located at period 2. So the electron arrangement is 2-1, but it converts into lithium ion. It will become 2 in terms of electron arrangement. For chlorine, it's 2-8-7, and then to achieve stability, it will become chloride ion 2-8-8. So you need to draw that. So for lithium, you need to draw the 2, which is it is left with a single shell with 2 electrons. For chlorine, the third shell has 8 electrons now. However, one of the electrons is coming from the lithium, right? So use a cross for that, right? So 7 electrons from the original chlorine, and then 1 more electron coming from the lithium. See? Donating electrons, right? Next, explain in terms of attractive forces between particles why lithium chloride is a solid at room temperature, but nitrogen trichloride is a liquid with a relatively low boiling point. Now, we need to mention their attractive forces. So lithium chloride is an ionic compound, so it has ionic bonding. Whereas for nitrogen trichloride, it's a covalent compound, so it has weak intermolecular forces of attraction. All right, so ionic bond is stronger than the weak intermolecular forces in this compound. So with that, it will lead to more energy is required to overcome the attractive forces in lithium chloride, leading to a higher boiling point. Or should I say leading to essentially a higher melting point, because we're talking about solid. And then for nitrogen trichloride, less energy is required. So it will lead to it having relatively low boiling point. Right? Ultimately, you just need to measure ionic bond as 1 mark, weak intermolecular forces as of the 2nd mark, and then you can say about the strength of which is stronger. So ionic bond is stronger than weak intermolecular forces. That is actually enough for this year. The 3 marks are awarded based on these 3 marks. All right. Next question. The reaction scheme shows 5 organic reactions, number 1 to 5. Name reaction 1. So reaction 1 is sugar to ethanol. That's actually just fermentation. B. Name reaction 2 and state the chemical equation for this reaction. So ethanol converted to carbon dioxide and water. This reaction is actually combustion. And the equation is ethanol converted into, in the presence of oxygen, because it's a combustion reaction. In fact, it's a complete combustion reaction because it's clean, you see. Otherwise, it would have formed like soot or carbon monoxide. But it's clean. It produces carbon dioxide and water, which means that it's a complete combustion reaction. So ethanol reacts with oxygen, and that gives you carbon dioxide and water. Next one is about balancing. Now, how to balance this equation? You balance it from the carbon first. Right? So it's a 2 carbon atom getting oxidized here. So 2 carbon dioxide molecules. And then hydrogen is having 3. As you can see, there's 6 of them. So here you just put a 3 in front. And then finally, we look at oxygen. Oxygen on the right-hand side, altogether, there's 7 of them. And on the left, there's 1 already. So this one, we need to put a 3 in front. Right? I will say that this equation is not easy to balance, but it is doable. Right? Just be careful. And you should be able to get 3 marks as of the reaction, the reactant, and the products. And also the last mark is on the balancing part. Now, next question. Reaction 3 forms ethanol from alkene A. So, how to form ethanol, which is a 2 carbon ethanol? You need a 2 carbon alkene, which is an ethene molecule. Right? State the type of reaction that occurs during reaction 3, which is hydration, because you're adding water to alkene to make ethanol. Right? You can see addition of water. Right? To be more precise, addition of steam. Okay. Next, state the reagents and conditions needed for reaction 3. So we need steam. Right? We need to carry it out at 60 atmospheric pressure, 300 degrees Celsius, and an acid catalyst. Right? In order for this to happen. Next, alkene A is converted to alkene B in the reaction 4. State the reagent and conditions for reaction 4. So we're converting ethene to ethane. That is possible by hydrogen. Right? Hydrogen, like addition of hydrogen. So addition of hydrogen requires, like, for example, nickel as a catalyst. And generally at around 150 degrees Celsius for the condition. Right? 2, state the general formula for alkene. So it's actually just CnH2n plus 2. Next question. Ethanol is oxidized in reaction 5 by heating it with dilute sulfuric acid and one other reagent. Identify the other reagent in reaction 5. Let's look at reaction 5 real quick. Reaction 5 is an oxidation process, as mentioned in the question. So, oxidation process requires an oxidizing agent. Example is acidified potassium manganese 7. And name the homologous series compound C belongs to. So, alcohol gets oxidized into carboxylic acid. And finally, draw the structure of compound C. So we need to draw the 2 carbon carboxylic acid, which is actually just ethanoic acid. So draw that 2 carbon. Functional group is COOH, and the rest is filling the remaining carbon atoms with hydrogen, and we'll consider it done. Right, so that's the structure of ethanoic acid. Okay, next question. This question is about polymers. Polymer X is a condensation polymer. Part of the structure of polymer X is shown. How many molecules of water are produced when this part of polymer X is formed from its monomers? So in 3, we see that there are actually 3 linkages here, which means that 3 molecules of water need to be removed from this reaction. Excuse me. All right, 3 linkages. So you need to remove 3 water molecules. Next, complete the structures of the 2 monomers used to make polymer X. Now, essentially, it's a condensation polymer originating from a carboxylic acid and also an alcohol. So you need to complete this diagram by, actually you can start with copy and pasting what's recurring. As you can see, this is recurring for the white units, and the gray units, this is recurring. Right, you copy that first, then fill in water back. So that can be done by putting water, okay, OH to carboxylic acid and H to alcohol. And that is done. All right. Next, what type of condensation polymer is X? Because it originates from a carboxylic acid and also an alcohol, so it's considered as a polyester. Now, next, part of polymer Y has the structure shown. State the number of different types of monomer needed to make polymer Y. So I'm seeing 3 units here. Oh, different types of monomer. It's the same monomer, so you just need one type. It's the same monomer. It's just a repeating monomer. Sorry, repeating structure of the same unit. Right? So one type. Next, part of polymer Z has the structure shown. Draw and name the structure of the monomer which forms polymer Z. Show all of the atoms and all of the bonds. So we have to draw back the monomer. You can first start by copying the repeating structure. Right? This is the repeating structure. So what's next is, you just need to convert these 2 single bonds into a double bond. Right? So what is the name of this compound? It is just but2e. Because you see that it has 4 carbon and the carbon-carbon double bond is in the center. So it has 4 carbon but and the carbon-carbon double bond at the center, so 2e. Now, next question, name the chemical process used to make the monomer that forms polymer Z. That is just, give me a moment, monomer that makes polymer Z. Or how can we make this monomer? That's the rough idea. So it's made by cracking hydrocarbons. Right? So that's all for the discussion for this paper. Thank you for watching, and I'll see you in the next one. Bye.